My name is Matthias Trobbe. Our demo is situated in the domain of efficient building management. Today's building management systems and HVAC systems in large buildings, like office buildings, hospitals, schools, etc., are often very complex systems. They contain a lot of sensors to monitor the functioning and performance of different subsystems, like pumps and valves. However, building automation providers and facility managers often lack the time, the expertise, and also the tools to analyze all generated data in detail to optimize these systems in the best possible way in terms of energy efficiency and comfort for the building occupants. Our approach is at the front in two ways. We bring all relevant building data together, BMS data, but also IoT data from additional sensors, structural info from BIM models, and user feedback from the occupants. And second, we design intelligent combinations of knowledge-driven and data-driven AI techniques to extract the maximum of useful knowledge from the available data to, for example, detect issues in a building like configuration errors or systems that require maintenance, and build tools that help with an optimal and automatic control of the building systems. The solutions we are developing receive already a lot of interest from companies active in the domains of building automation and facility management, as well as energy service providers. Examples are Basics, DeltaQ, Building IQ, Hysopt, Spacewell, Johnson Controls, Quares, Bureau Bouwtechniek, etc. With some of them, we are currently actively setting up research collaborations. The concrete use case we implemented focuses on the safe return of employees to their office buildings in the current COVID-19 pandemic, of course, when the situation allows it. At that moment, a close monitoring of the indoor climate will still be crucial to minimize the risk for new infections. Employees should be warned to take action, for example, opening a window or lowering the amount of people in a room, when the conditions in their office are not optimal anymore with respect to the spread of COVID-19. However, in most buildings, occupants have absolutely no idea about indoor air quality. This is often not even measured. Based on literature, we designed a methodology to calculate the risk for COVID-19 spread, taking into account air quality parameters such as CO2 level, temperature, and relative humidity, and also loudness as a proxy to estimate activities within an office room. By combining easy-to-install sensors with a number of ID Labs data and AI tools, such a real-time COVID-19 risk indication service can be set up in a very easy and efficient way. In every office and meeting room of floors 9 till 12 of iGent, we installed sensors to measure air quality and loudness data, like this one here. The interoperability middleware Diamond was used for the efficient integration of these sensors. And the data is then stored in the IoT data platform Obelisk. Via the RML tool, the raw sensor data is converted to semantic data, and this semantic data is then processed by Streaming MASSIF, which is a tool that allows to reason on real-time streaming semantic data using a knowledge model of the building environment. This knowledge model is an ontology that combines sensor metadata with location information extracted from the building's BIM model. The COVID-19 risk indication service is implemented in a declarative way on top of Streaming MASSIF, and the resulting risk estimation scores are then visualized in a semantic dashboard. In case of high risk values, extra rules defined in Streaming MASSIF can trigger actions such as warning users of a room, or in the future maybe automatically opening a window. In the dashboard, these high risks can be easily analyzed by inspecting the specific sensor values that caused these high risks. In this demonstrator, we'll show how we can compute the COVID-19 risk values using Streaming MASSIF in a fully declarative way. Streaming MASSIF allows to define a processing graph. An example is shown here, consisting of various components. The filtering component is the most interesting one and allows us to perform the analytics. We illustrate this with a simple temperature example. So basically what we do is from the data stream, we extract all temperature observations with their values and the sensor that made the observations. Then we combine this data with the metadata from the sensor and extend so its location. Note that this metadata is not part of the data stream, but is retrieved from the metadata database. Next, we combine the data with the logical name of each location, which is part of the BIM model. So Streaming MASSIF allows to hide the complexity of where the data actually comes from and allows to query this data as one uniform data model. Finally, we group the data by location name and compute the average temperature values for each room. We can then retrieve data, and we see that using this declarative language, we were able to compute for each office the average temperature value. The computation of the COVID-19 risk scores is done in a very similar way. Instead of only computing the temperature values, we compute the CO2 values, the humidity and the pressure, group these and compute averages, and then perform some additional analytics, which you can see here, and which is also done in a declarative way. Again, with retrieving some data, we can see that we have computed for each office the air quality risk, the thermal risk, and the combined COVID-19 risk. So even for this more advanced analytics, we were able to fully define it in a declarative way using Streaming MASSIF. The COVID-19 risk values calculated by Streaming MASSIF can be visualized in our dynamic dashboard. As an example here, we have a heat map visualization that shows the real-time COVID-19 risk values for the different rooms on floor 10 of the iGent building. The dynamic dashboard allows to monitor different sensors of the building and dynamically map those to different visualization types. To add the visualization, we click on Add Widget. We first select the sensor we want to visualize from the list. Here, for example, we select the virtual COVID-19 risk sensor created by Streaming MASSIF. Then we need to select the properties we want to visualize of this sensor. Let's say we want to visualize the risk indication and the air quality risk indication. Then, based on the semantic description of the sensor and its properties and the semantic description of the available visualizations that are in the dashboard will only suggest visualizations that are adequate for the selected sensor and its properties. So let's now add a line chart, which then shows the selected data. Apart from the monitoring of real-time data from the building, the dynamic dashboard also allows to inspect different types of anomalies. For example, when Streaming MASSIF detects that the COVID-19 risk indicator gets too high, it sends a semantic anomaly event to the dashboard, which appears here. And we can then inspect the specific event. The dashboard then will automatically create different visualizations based on the sensor that caused the anomaly. Obviously, the risk indication is plotted with the red dots indicating the anomalous part. And then we have also the other sensors that were used in the calculation of the risk indication. So we have the loudness, the relative humidity, the temperature, and the CO2 values. With this demo, we showed how the data and AI tools we designed at IDLab allow to efficiently design and set up new services combining different data sources within a building. The COVID-19 risk indication service will be used to support the safe return of IDLab's employees to the iGent building when allowed again. There are also concrete plans to deploy the same service in the Beacon in Antwerp. As our tools are based on a generic semantic knowledge model, redeployment of the COVID-19 service in another environment is very easy. We also expect a high potential for similar services to monitor for other types of diseases like the flu, or to improve user comfort in general in indoor environments. Thank you for watching, and feel free to contact us if you have any questions.